So quick story, y'all, my intro music. So one summer, I was teaching at a school that Mr. Murphy was at. And they had this hook, and I loved it. And they had the little kids who were ranging for age from 10 to 15. How old was the kids? 4 to 15. And the hook that they used was touch it, read it, learn it, teach it, everybody talk about it. So ever since I heard this, this has been my hook I use for all my videos.
You just recorded all of that.
Yep. All right, here's our learning target. I can determine the future value of a periodic deposit or ongoing investment. Let's go. So in 3.8, what we want to basically talk about is what if we have an investment that we want to have down the road in the future? How much do we need to be saving today in order to have what we want tomorrow? You know, a lot of times you'll hear people talk about their retirement or what they're going to do after they stop working. This is the idea behind that. And so there's two formulas. One formula is if I'm making one single solitary investment, you'll see the one up front, this guy right here. And the other formula is if I'm making multiple investments each and every month. So let's just jump into a problem. So question number one, Martina will be attending 4 years of grad school and 4 more years of graduate school. She wants to save a total of $200,000 in her savings account for when she graduates in 8 years. How much to the nearest dollar must she deposit in an account with 2.6% interest that is compounded on a monthly basis? Now, I love this. I love the fact when I do something in advance and I see, I made a mistake. And I got to redo it in front of y'all. So initially, I set this problem up and I said, to earn $200,000, she must invest blank over the period of 4 years. Is it 4 years? It's 8 years. So she's actually needing to do this for 8 years. All right, so 8 years is what we're looking at. So will the numbers change? Absolutely. So watch it. So here we go. All right, we're back. So actually, at some point in time, Mr. McCray did catch the fact that I made a mistake, and I adjusted that time. So what it is that Mr. McCray is asking you to think about is in step one, let's address everything that's inside the parentheses. And by that, in the calculator, what I'm going to do is I'm going to use the parentheses key, put my 1, add that to the fraction. So in this fraction, my rate was 2.6%. I turned that into a decimal. The number of times I compounded it was monthly. How many months in a year? 12. I take that same number of 12 and I multiply it by my years, which is 8. And I'm going to have a value that I store under X in my calculator. I store that under X. So this whole term now, for me, becomes X. All right, in step two, I took the value of X and put that in my denominator. In my numerator, I put this $200,000 investment. So $200,000 right here, divided by X. And what I see is that my final number is $162,478 need to be invested in order for me to earn $200,000 in 8 years. In question 2, my Kate question. Kate wants to install an in-ground pool in 5 years. She estimates that it's going to cost $50,000. I guess someone close that door. Thank you. Shut the fuck up. Guys, I'm recording. It's a family show. So I'm trying to figure out, wait for it, how much she's investing on a monthly basis, because it says she deposits blank monthly into an account. So I'm going to use a slightly different formula. Here's the formula I'm now thinking about. Bear with me. This formula represents money that's being deposited every single month. The first formula represented a single deposit. So let's take a look at what we did. In step number one, everything inside the parentheses I wanted to address. So I took 1, I added it to my fraction. We see that we have interest of 3. That turns into a decimal. We also see that we're being compounded on a monthly basis. That's where we get our 12. And we see that we're trying to do this for 5 years. So there's my 5, there's my 12. I have to subtract that parentheses from 1, and I get this value under X. So everything in the denominator now, I can express as X, and that's this term here. Finally, we move to step 2. In step 2, okay, we take a look at the investment that we want to make of $50,000. We multiply that by the fraction. The fraction should be our interest rate divided by the number of times we're compounding it, dividing it by that number we stored under X. And what we now know is, in order to earn $50,000, she must invest $773.43 on a monthly basis for 5 years. Take a moment and capture that. All right, in our next example, we see that the daughter of Alyssa was born. When she was born, Mike, which is I'm assuming the husband, began saving for her wedding. They wanted to save up $30,000 for their daughter's wedding. $30,000. Okay? And they had 20 years that they were working with. All right? So, again, how much did they, when they made the deposit, was it over time or was it a single investment? One time. That is the key to determine how I'm moving. Am I moving with that first equation or that second equation? So that being said, you said it right. Moving with the first equation. Okay? So, knowing what we know, again, we isolate what's inside the parentheses first, and we're going to set that equal to X. In this case, that X value is 1.8 something, something, something. In our second step, we simply take the investment of $30,000 and divide it by that X. And in this case, what we see is, if I'm doing this for 20 years, I need to be putting $16,000 away every month to get to the $30,000 mark. $16,000. Okay. All right. No, I misquoted that. I'm sorry. What did Ms. McCray say wrong? What did I say wrong? I need to be investing $16,000 every month or one time up front? That's right. One time. One time. I love it when you guys catch me. All right. In our Anthony example, we know that Anthony wants to repay the loan his parents gave him in 3 years. Maybe he bought a car, maybe he started a business, we don't know. We do know this, the loan amount that he started with is $35,000. We also know this, he wants to make a payment to them semi-annually. If annually represents 1, what does semi-annually represent?
Double.
2, double, thank you. Represents 2. All right, and that interest rate is what he is working with. So again, let's take a look at our numbers. Okay, all right, because this is not a one-time shot, we're going to use the second formula. Let's isolate the denominator first and set that equal to x. In this case, we should have something that resembles that figure. Step 2. Shanice, I know you're done, but bear with us. In step 2, in our final example for your notes, we're dealing with Uncle Al. Anybody got an Uncle Al besides me? Uncle Al. So what do we know about Uncle Al? He opens an account, for his niece and nephew because he wants to put away, this is a good uncle, y'all. He wants to put away this kind of money for their future. He wants to put that away for them. Maybe uncle is there because dad's not there. Maybe uncle's hands-on because their father wasn't hands-on. But he's putting this money aside for 25 years. So which formula are we working with? Who can tell me which formula will we be using? The monthly formula or the one-time deposit formula? Monthly. Four. You're 100% right. So we're making a one-time deposit, and we're looking at where the money takes us in 25 years. The goal is we're trying to get to 100,000. Okay, so step 2 takes us to us taking our investment, our future desired goal of 100,000, and dividing it by the value we stored under X. And here we have it. Okay, we need one time to put aside 64,000 or 64K in order to have 100K in 25 years.
So do I do another equation?
Yes, that's where we are. All right, did we get through all the examples in the class?
No, we got 2 more.
We got 2 more examples. All right, let's just get them up. All right, we got 1 more to go. But well, here's what we know. 30 grand. To get to 30 grand, what we want to do, we want to invest this on a monthly basis for 1.5 years. By the way, some people had trouble, I think Shanice had trouble with this. 18 months is just 18 divided by 12. That's how we get a year and a half. Okay? Don't get caught up on something real simple like that. Okay? Final question. Okay. Capture this, guys. So we know that we're working with 40 grand. We know that we're doing it for 4 years. We have an interest rate. The only thing we need to ask is this a monthly or is this a one-time investment? All right, so in summary, I'll stop the video and got out of my nature. In summary, in order to get to 40,000, we needed to invest 33K for 4 years. 33K for 4 years. You will have some practice problems that are much similar to this that I want you to take a shot at. All right. All right, so please go ahead and pause the video. Get started with the practice problems. And actually remember that consistent study every day keeps 4 grades away. All right, class, y'all got 5 minutes to get yourself wrapped up.